Okay, so I don't know if I'm going to splice this with the other video that we did, but we're probably going to have to do that. So anyway, so I was saying about how, this is pretty much what we're doing. So we're going to put this to the side. So we're going to start again by folding. We have the rectangle. And then we're simply going to take this edge, this value, and put it towards the center of our division like so. So what we do here is make sure that the edge of the rectangle falls on the middle line and that it goes to the other corner. Let me just make sure that. Okay. So from here, what we do have is, as of now, so you can imagine this to be the edge of a triangle. So therefore, the bisection of this, and by this I mean this, so you can even see the shadow of the object. So it's sort of how we approach the problem. This could be the center of a triangle, or you can have a triangle go through the center there, and this would be the middle. I can't sort of picture it right now, but this should go through. It's weird to me right now. I don't know why it hits there, because the middle seems to me that it's more like here. Interesting. So we're going to then keep it inside of a triangle. Let's see. So we're going to fold this as a shadow. So we're going to use this as a reference and fold this back like so.
I'm sorry. Just a second. Can you open that up?
Yeah, let me go over that again. So it's as though this is sort of doing a bounce on the edge of the paper. So let me go over that again. So first fold was the middle line.
Yeah.
This was the first thing we did. Afterwards, we folded one of the corners of our paper toward that line. And so what we want to do then is just make sure that the fold is starting from the corner and that the other corner is landing on the line here that we drew. So this fold that I did right after is pretty much just using this remaining edge here and sort of doing a mountain fold on it. Pretty much is just sort of a way of doing a mountain fold, but
you always turn it over and fold the other way. You don't fold that, the third fold, you don't fold it down over the top. You just flip your whole paper over.
yes. The reason being that if I fold it on top of it, so if I go like this and just go on top, there's a chance that the overlap might produce some sort of inaccuracy here.
Okay.
So
So to be more accurate, you turn it over.
Yeah, it's to be accurate. But you can also do it in this way where you sort of undo the first fold.
Oh, yeah.
Like I did here. So I undo it, and then I can take the remaining edge and just land it on the fold. So that's another way of doing it.
So when you say this thing about bouncing, what do you mean? What does that mean?
So bouncing to me means that a fold or a line is hitting an edge. It could be a folded edge, or it could be sort of the outer edge. But the way that it comes in is the way that it comes out. So the angle that's sort of incidenting here on this line is the same angle that's going to come out over here. So it's going like pop, pop.
It's like playing pool.
Yeah, like playing pool or that Pong game. You remember that Pong game though?
Oh, yeah.
First, yeah, like that. So it's sort of like the line is going, it hits, and then it bounces back out, like that DVD screensaver.
Mm-hmm.
So we have a triangle now. So this is pretty much, so we're going to try and work within this triangle. We can cut at it. We can simply, get rid of the excess line. So for our construction right now, we're going to cut everything that's not a rectangle of the triangle. So what I like to do for this step is I fold the side of this triangle that has the excess. That is to say, this side for me, the right side for me. Because on my left side, my corner of the triangle is falling exactly on the edge, on the very, very vertex of the thing. And so what I want is to have the same thing on the other side. Therefore, I fold this, and then on that point, I simply can lift this paper up from there, like so. So because my objective is a rectangle, which is a parallelogram, I'm gonna have this edge. Well, the fact is that we're also starting with a parallelogram and a rectangle. So we're sort of just using that as a guide. And by that, I mean, well, it doesn't necessarily have to be this way, but notice how this line is falling on itself, this middle line right here. This is itself, this line that's on the back there. It's the same line. So that's falling on itself, but also, and I feel that this is the bigger reference, is that on the edge over here, this little edge, this line, this edge is also falling on itself here. And this bit is what we're gonna cut off. So we wanna make sure our two things pretty much, that when we unfold this, it looks like this, where we don't see the excess. If I lay it down flat, you see that my edges are not protruding, but rather just really as much as I can make them, and they're falling on that point. So point, and the edges on the upper and lower are not protruding, right? So it's a way of guaranteeing perpendicularity. If I turn it over also, you're gonna see that this line is falling on itself. You can see there. All right. And so this we're gonna cut off. So what I'd like to do is I'd like to just drive my nail through it real hard and then unfold. And so what I've done here is pretty much just really, really nailed it down. And so I turn it over, and now I'm gonna see it as a mountain. I fold it as a valley, and then I go again hard on there. And now that the fold is strong both ways, I can rip it off easier. I can sort of do a rip, and it's easier for that to travel along. Now we don't necessarily have to cut at the paper, but I find it's easier for working with something, because in origami with paper folding, for a fold to be mechanically useful, you need to let it actually go out. One way or another, your fold has to somehow exit the paper. And by that, I mean, if you imagine the line to sort of be a path, then it has to hit the edge at some point. It can bounce. This line doesn't have to end up here. We can do this little bounce and then, but it has to go somewhere out. And so that's the interesting part of this. Okay, so we have this for now. So now we want to just establish some definitions here. So not definitions, we just want some identities. In order for this to sort of work the way we want it to work, we're gonna put the 9-fold center at the middle of this triangle. So first step, if we're getting a 9, we need a 3. The approach we're gonna do for the 9 is trisecting a triangular division. So a 3-fold division, we're gonna trisect that. And so 3 by 3, we get 9. So first I start by folding my paper in half. Now I say folding my paper in half, but you can also appreciate this move to be the bisection of this angle, because this line is falling on this line, as you can see there. So we're gonna do the same bisection on all of these corners of our triangle. So that was 1. So now over here is 2. We're gonna see how the edge perfectly lines up to the top here. So we fold that. And then same thing on the other corner. So as you can see, the things we do have many names. So we can call this a bisection. We can call this sort of a move where we're translating or taking a point to another point by folding. But it gives us this same result. So in origami, and it also works in geometry, but usually they don't really express it like that. For a pattern to be n-fold, you need to also have the lines that go to the edge, to the midpoint of the edge. So if we had a six-fold division, it sort of does require us to have another line there, but we're not going to worry about that. So we're going to try and first off extract this threefold. We're going to mechanically activate this threefold. So I want to turn my paper over in order to have the lines that go to the center. This line, these three lines, I'm going to mark them with a pencil here, just because to make them more visible, I suppose. And we're going to sort of activate all three mountains at the same time. Now, because, as I said, a fold has to exit the paper, we're going to see how this line is going to turn itself into a valley. So here goes. So one mountain, two mountain, and three mountain. I start to activate them. And as much as this is sort of lifting for me and giving me some space to work with, what I really want is for this move to be done. Like I want this to be able to do. So you can see there that, you know, this is, you can see it like this also. So this is what we're looking for. And this is what makes it the official threefold, if you will, because we have a valley between our mountains of division. And so now we can actually appreciate this to be divided in threefold. So each of these now has to be divided into ninths, well, each of these into thirds, right? So it's already a third of the full division. And so if we put three more folds into this, we're going to get a 9. So I'm going to choose this leaf here. So there's three of them, right? So I take two and I lay them on the ground like so, and there's going to be sort of an additional one, right? So this is the thing we're going to divide, okay? So here's how the threefold division sort of goes for me, the way that I figure it. So this is also an approximation, but it is pretty useful. And you can always tinker at it and actually get to the more proper ones. So here's how you do it. You start by bringing this down. So you want to be able, so the reason we bring this down first is to just establish our division. So here I'm just establishing that it's sort of matching. I don't know if you can see there, right? But you can see, so I'm make sure that the fold that's going to come out toward the cone shape here is sort of starting from the corner. That's what I want to make sure. Just make sure that it's sort of properly able for me. Okay, so once I have that, I pinch it, and then I produce a wave. So I pinch, I produce a wave, and then what I do is I fold like this. I don't know if that makes sense, but the idea is to have the pinch land on this middle line here, and then what's coming out of the wave lands on where the pinch is going in. So we're trying to match these three. And by three, I mean 1, 2, and 3. Well, this, yeah. 1, 2, 3. And so for this proper pinch to work, and something I find that I always have to take into account is for right there, for this fold to actually get to the end. So notice how it's all messy right now because I haven't defined anything yet. I just want to make sure that these folds are lining up. So I want to make sure it looks like that. Before I sort of commit to this, what I want to make sure is just that the layers can properly And so for instance, on this one, if I bring it down, I can see there's a mistake. Namely, that if I start to bring it down, I can clearly see there that this line is crossing. You see that? How this line is going over my middle line here. So therefore I need to push that out. So that layer is a little bit too much. That layer is this one, so I push that out a little bit, and then everything just sort of starts to compensate. And so because this one also has to fall on that, so I start to sort of bring those together. And then I again check before I commit too hard and see how well that lands. And so I can give it a little more. So I give it a little bit more and then fix that to that one, make sure that these two are touching, right? This one and this one have to be touching. So I can sort of just push and pull and then, you know, adjust for these to touch and then, you know, open it up a little bit and see where it's landing. And, you know, that's a lot better. You can see there on mine how, you know, that fold is originating on this line. You can see there on the inside as well how these two are matching. So it's this one that's coming in and it's touching with that one as well. So here, let me take out my phone. I can't use it that much because it would be on data, but I want to take it out for some detail shots. Let's see how this looks. Let's see. Okay, there we go. Let me see, let me set this up properly, but here, some detail shots of this. Wait a minute, because I do have a tripod for this thing. How you doing, Jeanne?
I was pretty close and then I was off, and I'm trying to figure out how to get back.
Yeah, so try and think about it in those terms of sort of the pull and the push.
Yeah.
So if you see that a layer is a little bit too much, then now it gets a pull. If it's too little, then you push it.
Yeah. I'm pretty close.
My, oh my. My camera's having such a bad time right now.
This fold looks difficult.
Yeah, I don't know if how this is better.
It looks difficult.
It looks, but it's once you get the hang of it, it's actually pretty. You know, it just once you know what to do, it's just it's still sort of challenging, but.
It is challenging.
But see, this is sort of what we're trying to get at, that all these three are just landing on the same line. This is our reference line. So these three are on the same sort of, you can see if I can bundle them, it goes 1, 2, and 3. And so they actually are on the same sort of pivot line, if you will, on both sides. And so if I wasn't, I could push and pull these in order for these to sort of just match. Once I have the matching, everything else is just easy. We just need to do this once though. So the first time we do it is the only time we need to do it.
All right. I overshot the first time, I undershot the second time. So now I think I'm gonna get it.
That's the spirit. See, for me, I'm also tinkering on mine because I think that it could be a little better. Now let me close those blinds because now it's a little too bright. So we can also practice this pinch on another. So I'm just going to take this out just for reference right now, but just to show you how else we can sort of do the same move, but on another angle. So we're just going to do this one as an example. You don't have to do it, just to show you a little bit. So I'm gonna put in a center fold, and then I'm gonna fold both of my corners as though they were squares. Just as an example, just an example. And so what that does for me is that now I have sort of like access to this fourfold. I can fold one way. This one I can fold the other. So same deal as the 3, but this is 4, right? Same deal, same deal. And so if I were to apply the pinch, which is a little difficult, I must admit, but it is where we're at. You take the flap that you want to do. You open this cavity. And so also notice that my finger is inside, but it's only so that the layers there don't get separated. So those two need to stay together. So I can keep the finger inside, and then I pinch and twist. I do this pinch and twist, and then it lands. And so once I take my finger out, and then I start to sort of just bring it around so that, you know, this lands there and the other one matches to it. Sort of a back and forth and back and forth. Make sure that it's very, very spiky at the corner there. As spiky as I can make it. And so this is the example of how we would do it on the 4. So same trick, but now it's on a square. And so I can turn it over and see that, you know, it's a little bit off here, but I can sort of push it and pull it and push it and pull it and get it to where I need it to be. So again, just an example of how to do this sort of 3-fold division by pinch. So I know it's you know, it's a little daunting, But once you get one, then the rest of it becomes a lot easier. So you ready, Jeanne? How you doing with that?
I'm just gonna check.
You can always check by just sort of rotating around the axes that you have. So you can always like
it's not quite there. Just, I feel like I'm so close.
So try and identify which of the layers is the one that's overshooting or undershooting. And
Well,
try to sort of,
I think that my paper's so crappy. It's so folded up right now.
yeah. We can start over if you want, anytime. But it's good to have a sort of a draft, sort of like the initiation. So now that you got sort of like this shape, now what you want to do is just take this, so you can see that this one's going to be flat, right? It doesn't have the fold between. So you can simply just take sort of like the one adjacent to it, the flap, and just fold it one way.
Okay. And it should line up with that other side, right?
Yeah, exactly. So that's also a way that we can sort of prove that they're the same by congruency. We can say like, well, this one is the same as this one. I can see because they line up. And if that one lines up to the one on the left too, then the one on the right must be equal to the one on the left because they have the same thing they're equal to.
They're not really lining up all that great. I mean, there's inaccuracies here, but I think that there's something. I think it's okay though, Ricardo.
Yeah.
I'm just gonna put some pencil mark on what's going on here.
Yeah, so try and also move him like so, like I call this like the paper flip, the book flip almost, because you're almost like flipping through the pages of a book like this.
Yeah, they're good. They're good. Yay, hooray.
Yeah, so as long as you can sort of like do this little flip thing, then you're good.
Yep.
And so you just notice also that this little flip has 3 of them. So it has 1, 2, and 3. 1, 2, 3. And so therefore, if we have 3 of them and each were to become 3, then sort of like a multiplication by division, we multiply, sort of like that, sort of back forward analogy, if you will. So you have 1, 2, 3. And so we want to do the same thing for the other ones. And what's cool, or the advantage, is that we don't have to redo the pinch. We can simply just use this edge as a reference. And by that, I mean, we can simply just take this sort of cavity, open it up, just make sure that we're sort of coming out from the corner, yeah?
Hold
and
on,
just,
where I lost.
okay, so I have another of the full flaps. So I have my, so here's the 3 flaps that we just divided.
Turn that under, okay.
Yeah, so I turn this one under.
Okay,
so
got
that
it.
now what's happening is that it's as though it's like this, but now it's with all these 3 together. Because these 3 count as one of these full. So
Right.
we're still threefold. But now one of the threefold is 3.
Okay.
And so we lay those 2 down like so. So one of the full and one already split. And then we can take this cavity, and all we have to do is just line this one up to that edge.
Wow, okay.
So what I do here is I make sure that these edges are lining up. I don't want this to be separate. I want these to be together. So I just put my finger there just to make sure that those don't split on me. And then I just make sure that that edge falls on that one.
I'm holding underneath so they don't split, and I'm pushing down.
Yeah, and then you have to let go though. There's a point where you do have to let go, because if your finger stays in there,
oh, I see. You want to line up the side, the corner?
Yes.
Okay.
Like
the very tippy corner of the paper needs to be. Okay.
Yeah, lining up to there.
Yep. Okay. Okay. Just need to check underneath for a second.
Yeah, this is a little bit off for me because I can tell. I can tell that if I do the axis move, that it doesn't sort of make it congruent. So that's very important too.
Is it supposed to be? Am I supposed to be looking at a perfect triangle now?
On where?
God. Okay. Well, anyway.
So what you want to do is, for when you do fold it like this, so when you do, so you line it up. So I lined up that one to that one, right?
I'm looking, I'm not looking, mine doesn't look like yours. for some
Okay,
reason.
so let me just unfold this a little bit. So we were there, right? We were there where this sort of three flap here was happening, yeah?
Yeah, hold on, just 1 second. Let me put the
Yeah,
handle
yeah.
back there. Here, we had the 3 flaps. That one under. The heck? Oh my God. Oh, 1, 2, 3.
You got this, Jeanne, you got this.
I got it, man. Okay, got that. We did that. We looked at the 3. We folded
Yes.
that one under so that we had a little square looking thing.
Yeah. So you have this 3 flap, right? This little guy.
Except it might, I don't, hold on, show that again one more time.
Well, this one is folded because I folded, but yeah, it can also look like this. Depends on which one you put down. So you can put it on the left or you can put it on the right. But essentially what's happening is that, this 3-fold division,
Yes.
one
Yeah.
is split into 3s, right? And the other 2 aren't.
Yes.
So what's going to happen is that this angle right here, this angle from the center toward this edge,
Yes.
that's the angle that we sort of want to copy all the way around.
Yeah.
So what we can sort of solve for it is to simply just take like that, the edge on the next one. So it's sort of coming in from the corner, and we just make sure that that lands on the edge, if you can see that. So my fold is originating from the center of the paper. And what
Can
I'm
I
doing
show
is
you what I, do you mind if I show you what I have?
yeah, please.
Okay, so I have, I'm here. I got my 3, 1, 2, 3 here.
Yeah.
I got this part here, it's sort of like a square. This part here is sort of like a triangle. I fold the
Yeah.
triangle back behind, and now it looks like this. Got my 3 right here.
Mm-hmm.
Got this edge up here, and I'm trying to make this edge. Trying to make that fold along there.
Yes, yes. But see, what's happening for you is there's going to be a complementary fold happening on your left. So when you fold this one to there, there's going to be a fold that's going to be needed here also.
Oh, okay.
So it's almost as if, that's sort of like the complement. I don't know how else to say it, but so we had it like this, right?
Yeah.
So then what you're doing is you're putting just sort of from there, sort of the same angle, lining up.
Okay. I think
And
I'm
sort
just, I think I have it, except I'm just the reverse of you.
Yeah, no, you got it. It's just sort of the imagination there. So exactly right, exactly right. So what you can sort of fast track this, if you will, is if you can hinge this and just to make sure that it's correct, because if you can take this one
Yes.
and sort of take it like that to the left, it
It's
should
not
line
bad.
up with the line that's there.
Okay,
And
got
if
it.
it doesn't, you can sort of just pull and push and just make it be what you want it to be.
Okay.
So Richard was not satisfied with this approach to my 9 because I was like, yeah, it's easy. He just goes like, nah. It's not exact, he says. But you can make it exact. You can make it as exact as you can make it, but it's like that thing, you got to make it. It's not something you can just sort of fall on a formula for. It is, though. I mean, there should be a set of lines that we can sort of track and find in order to do this just by folding. There should be a way. But when when you can just do this sort of trick for trisection, then that becomes the sort of the go-to for me. But
So
I acknowledge that it is quite the feat.
But basically, you just keep folding around and getting everybody lined up so that however you can.
Yeah, exactly.
Okay. All right. I think I've made all the folds I can possibly make. At this point, does it matter if they're valleys or mountains or?
Well, it should go mountain valley configuration. They should go like, you know,
If
interchange.
I unfold the whole thing, I should have mountain valley, mountain valley, mountain valley, like a big star.
Yeah, exactly. So
I
you can
don't
solely
have-
tell that I'm a little bit off here. Let me
I
just
don't
fix
have mountain valley, every other one.
that. Well,
I'll
the
make it
one
that
that
way.
the remaining sort of flap that we have should be the one that's sort of breaking the sequence here. So this is a lot like sculpting.
Uh-oh, something's missing.
Yeah, so I'm really just doing what you said about just moving everything around and making sure that everybody's in line.
Well, I've accidentally opened everything up now.
Well, that's fine. That's also fine because the lines are going to go across anyway. So you can really just open it up and just take your lines all the way across. And that should solve for a big part of the thing. Like we don't really need to do it this way. So we can also just unfold it like you did.
Yeah. And
And
then
just really, as you can see, the lines are sort of extending all the way through. So for instance, this one, which is incomplete for me, which is what I'm looking for, I can just really just extend this. So I can extend that one. I'm missing this one I got. This one I don't got. Actually, this might be a little easier because these lines are also going to match to themselves. You can see how they...
Oh, yeah. That's good.
Yeah, this might be a little easier. So let's see, I'm missing this one as well.
So let's see here.
It shouldn't hit the corner of the rectangle. Not that I'm aware of. Like this line should not just perfectly match to there. It shouldn't.
It did.
But
It did. It came in a little bit on both sides.
Yeah, it looks very close though. Very, very close. So for me now, let me just go back to this little division that I drew up. So the idea is for this threeness, so this is the threeness, to be now divided into thirds. And the way that we sort of have to do that is to divide it into sixes. Because in order to apply the thirds, you know, mechanically, we need to have a line between. Sort of to account for the mountain valley configuration. So even though that I do have sort of like three spaces here, which I've trisected, what I really also do, maybe by inference there, is to sort of bisect between them as well. It sort of just happens. The reason being that if I look at the other three that I started with, and sort of I also see the threeness of divisions on this one, you're going to see that the bisection is actually also going through the lines on the other side. So I think that this is why it happens, because it has to sort of have that sort of going around kind of way. There might be just a way to just get the 9, but you couldn't like, you know, end up with a single thing. So once we actually fold all these lines, so all this division, now the challenge, not the challenge, but sort of the next step is to just collapse everything up into a single slit. So we choose like 2 of them, you know, because it's going to go like these 2 mountains, for instance. So it'd be like mountain, valley. I like to do like this more than the other way, like mountain, valley, valley, mountain, valley, mountain, valley, mountain. Do the same thing to the side. Valley, mountain, valley, mountain, valley, mountain. So it lines up to there. So again, because this is like sculpting, we can simply, you know, if we do have a mistake, we can just sort of, you know, take away from one and give to the other. And so it just always compensates you. So if you take away from one, then the other is going to be like, oh, wait, I'm lacking. So you give it some until it goes all the way around. Also, what happens to me often is not hitting the center properly. So what I like to do for those kinds of situations is I sort of find where this is happening and I pull it. I hold these points here on the top really strongly, and then I sort of push the paper up from there, sort of to try and lift it so that it does hit so that the lines are originating from the center. So that's what you want to do. You want your lines to be originating from the center. And so I'm just making sure that they all match at this axis line, this axis symmetry line here, so that I can have them all. So you can see that they're a little bit off on mine. I could probably do some improving on there. I think I may have chosen, not that it was wrong, but the thing is that if I had chosen the 3-ness in another way, it's easier to see the pinch, because as we did it, it actually sort of wasn't that obvious. So let me take out this drafting paper that I use sort of to prove that point to you, to show you what I mean. Because those kinds of things, although they don't make any like theoretical difference because they're all 3s, what it does do is that it's easier for us, you know, normal people, to see it. And that's what it's doing for us. It just allows us to better understand, to better approximate, because we can, you know, just see what we're doing better. So I'm just starting again with this drafting paper that I had here, again, just to sort of show. I'm not going to cut the rectangle this time. I'm simply going to stay with what I got. But what I'm getting is sort of the triangle, which I really don't need. What I really need are just the divisions of the 3-ness, but you know, it's whatever. So I have there, and then, so that's my corner of the triangle here. So that one goes up. You can see that actually I'm a little bit off in my triangle construction here. So here's a way that you can also sort of avoid getting this line. If you have these 2, which was the point coming down, you can sort of do a double mountain trick on there. And so then the question becomes, okay, so now I have the 3-ness. I have the 3-ness happening here. Okay, so then the question is, which one of these should I trisect? Which one is the easiest one to trisect? I think for me right now would be this one, but I can also sort of pop it back and see if there's an easier one on this side. For instance, there's this guy. This is the smallest of the triangles. You can see that it's all, with the advantage of this guy is that it's the same on both sides, and it's very small. It was very small that at least that if I sort of open it up and pinch it, I can then sort of appreciate that it's going to do the same thing on both sides. And then I can also sort of see where the pinch is going.
Mhm.
And so this one might be the easier one, you see. So then I can see, I can better appreciate this line is together, and I can better appreciate how this line is going to fall on that one.
Mhm.
And so there I can commit faster, because now I can see better that that falls there, and that the jump, or that this little curve that it does, that little wave is happening on this line. So how about we do this again,
Okay.
just to be sure. And now we're going to use this triangle that I find is a lot easier. So once you have this triangle, you just move it to the other side. You can guarantee that it's the same. And now it's just a matter of sort of copying this angle around. Or you can just really open it up and extend it. So this could be one way. I'm even going to do it like that. So let me take out another piece of paper here. Alrighty. I feel that I should even maybe restart the recording or something. Let's like pretend like this is the beginning. All right, everybody, welcome to the folding session. We're just gonna begin. All right, so we start by folding this in half, right? Get the threeness happening for us. So yeah, fold in half. Take a corner, put it on the line. And this time we're not gonna cut. We're not gonna cut yet. First, we're gonna focus on getting the 9-fold division at the center of this 3-fold division. So first step, that. Second step, on this corner, on this line hitting the edge here, we're not gonna go out. We're gonna go perpendicular. So you can simply, I'm gonna turn this over, and simply what I'm gonna do is sort of lift it and just match my corner there where the fold is hitting my edge there. I can sort of see it easier, and just make sure that on my right here, this is falling on itself. This line is just, it should look a little something like that. There should be some resistance here on this corner, and by that I mean that it's actually coming from that corner, from that point. And then a perpendicular. So if we open it up, we now have the line, the center line of this sort of triangle division. Now we're gonna bisect the bottom part with this part. So this line is coming in, and the edge of our square, we're gonna bisect those. So how we do it, we simply have to match one line to another, and the resulting fold will be a bisection. Once we have that, we now have a nice intersection of the threeness here. So these two lines are what we're going to trisect pretty much. We're going to try and trisect this, but we're going to trisect down here as well. So here's how this is going to go. I'm going to turn this over so that I have them as mountains. And then I'm going to just take this mountain and put it on the other one, like so. So again, it was like that. And simply going to take this one and put it over here. Whoop. So of course, there's going to be all this resistance happening, but I want to just have a straight line here going. So I'm not going to fold it strong like this, but I am going to match it. What's important for this fold is that these two lines here are touching. That's what's important right now. Like so. And then what I did here is simply take this resulting mountain fold and just make it into a valley. So that now I have a threefold, yeah? And we saved up on a fold. There was one fold we didn't do. Okay, so now we're gonna sort of bop this. So we're gonna take this point and bop it. And so bopping is pretty much just making things close either one way or the other. So it can either close toward us or away from us. So it can go like this or it can go like this, pretty much. So it can go fingers up or fingers down in this case. So this is fingers down, if you will, or I can bop it and it'll start closing toward the top here. And so what I wanted was to be able to extract this guy. This is the one I'm looking for. And if we sort of do a little analysis on what that is, it is the smallest triangle on the edge. So it's the edge, the center, it's the smallest line here. And we have it as everything between it. Well, now we have this guy. This is the guy we're going to trisect. This is who is going to get trisected. So first, what I do is I open it up like a ball to make sure that the fold or the line is coming in on the corner. So if I'm not going to commit to this. I just want to make sure that the fold is sort of happening on the corner. We're not folding anything yet, any line. What we're getting is just that this hole goes all the way to the end. This is all we're establishing right now. Okay, with that established, now we can do the pinch. We pinch. And so now we descend the pinch towards, it could go either left or right, doesn't really matter. And so what you want to do is sort of, you want to pinch and start to bring down, pinch and bring down. And also make sure that the pinch line, so like this line is going to come in like that, the sort of like wave line is hitting the bottom here, that point. Very important because that's sort of what we're doing. This is the whole purpose. So I do a lot of motions on it to make sure that, it's actually on it like so I can, just to gain control of the thing. So even if the line is not folded, I just, by virtue of having just like a little bridge there, I have now control as to what is happening. So you can see that I'm pretty close to the ground here. Well, it was better, yeah, to the ground, because I need these two to go together. So this is hard to do in the air. So this is something that maybe should be done on a desk or a flat surface. But notice how I'm getting very close to the ground and still there's no commitment done. I haven't folded anything strongly and yet I have a lot of control as to where these lines are going. So I want to do is I make sure that, I either pull on this down or push on this top and make sure that it's just lining up with that line. So this is the advantage of using this triangle, that I can use my left hand to hold this together and my right to sort of move this and make sure that this is falling properly. And I can perfectly see it. I can perfectly, you know, just establish my division here. If I'm missing something, then I can just correct it if it didn't go like I wanted to. So it's easy and quick to see and check. And once I'm satisfied, I keep this together, these with my fingers, I keep these together, and then I fold the compensating angle. So this is the first one we do, and this is the resulting compensation. So now it should look a little bit something like this. I'm pulling my hand here because the shadow actually makes it so it doesn't burn the camera a little bit. I don't know, it can do it sometimes, I don't know. So this is way, way easier than the first method we did, isn't it? Maybe it's also because we got a little practice going on. So with this established, everything else should just sort of fall into place. Now to do that, it's sort of easier said than done. But first step we want to do this is the guaranteeing factor. We take this little guy that's the sort of the main between, and we take that from the right to the left or to the left from the right, depending on which side you went for. But we simply just take that to the other side. And we make sure that this other sideness also occurs on the center line. And so what this establishes is congruency between my right and my left. So if I can fold to the left and have this sort of vertebrae, or this like spine, if you will, this middle line here, if I can have this line fall on this edge and on this edge, I do this thing where, well, this is equal because it has the same sort of axis. So then this angle is the same as this angle. And then I take it to the right, and so same thing, this angle is the same as this angle. So if this is equal to that, and this is equal to that, these two are equal. So by that, we sort of have now equal right from left, and we have a middle sort of spine here. So now comes the fun part. We can either, you know, we can either fold based on this edge, these two, or we can simply extend these lines, and that should give us everything we really need. So let's do the extension. So as you can see here, I'm going to turn this paper over just because I have it written down here, so I can just complete this drawing I have. So I'm going to just take this line all the way across. Now I'm going to draw in all of my lines, which I have folded here. There's going to be 6 of them. It's cool, or it's better, I believe, if you actually distinguish between mountains and valleys. That is, if you have 2 color pencils. I think that's better. So if you have a green and a blue or something, you see that it's like a valley, mountain, valley, mountain. It is sort of easier to appreciate the nuances and the details if you do it like that, I find. So these are the lines that we're going to get extended. Just focus this thing here a little bit. There you go. All right, so by extension, I mean that, for instance, it's easier to extend based on the line than what it is. So this is also why I suggested the different colors. But see, this one for me is a mountain. So I'm going to do the extension in a mountain. So I'm going to take this and just make sure that it's a mountain all the way. So something I can do and guarantee that this is actually proper. Notice this line is falling on itself, and so is this one. And it's going through the center. So that way we can sort of be sure that what we're folding is guaranteed to work. Also some nice things here, matching. Nice little match. We unfold. Nice, so now this line is fully extended. Good, good. Now we're going to extend the next one. Now this one is extended in a valley. Well, this is a valley, so I'm going to extend it in valley form. Again, these lines are going to match up to themselves here. And line goes to center. And so far, that's all we got. So boom. So the thing is, there's only going to be one fold for every distinction that we make. So it usually is that a distinction requires two sentences, or two definitions, or two things that are connecting. Sometimes it's not enough to say that one thing is connecting. Sometimes you do need to say that two things are, because of the way that it could be interpreted. Because if I just told you, make the line fall on itself, there are many lines which satisfy that condition. But there's only one that has this line fall on itself and go through the center. Only one. And so we take that into our sort of our mindset. And what we do is we have faith, is what I call it faith. So, okay, so if there's only one fold for that, and I can establish this condition set, then if I just sort of really just take it, I know that that's the only fold it's going to be. So just go all the way and that's it. So now I have a nice little bisection here. So we're going to keep this going. So I have this one in the middle. I have now these two that I have to do. And so here's a little tidbit, a little detail of information for you. On odd number polygons, these lines are going to change state when they go after they cross the center. So the question you have to ask yourself, is 9 an odd number? The answer automatically, yes. All right, so what does that mean? That means that if we have a mountain coming in towards the center, after the center, it's going to come out as a valley. So here's how that might look. So for instance, I'm going to take this sort of mountain valley. So, okay, so if this one is a mountain, then this one's going to come out a valley. This is a valley, this one's going to come out a mountain. You can see that clearly there. So what I'm doing right now is just changing the folds to be sort of the proper way of doing the 9. And by that, I mean that, you know, if they come in a mountain after the center, then I change that into a valley. And so, okay, so notice how this line is coming in a valley. But after the center, I have changed it into a mountain. The same line goes valley, center, mountain. Valley, center, mountain, valley, center, mountain. Should look a little something like this. If we sort of collapse it, you can start to see it sort of come down. So here's another interesting bit of information. If we collapse it, we see that, well, for instance, this one already has a hinge. This side already has a hinge. But this side does not. So we can put that in. And it's actually going to match to the one on the left there. It's also another great way of guaranteeing that we're sort of on the right path. These two should just touch, just really. I'm glad we start over because this is so much better. So now I'm unfolding the hinges. I'm going a little bit too fast. I'm going to take a little breather. I'm going to use my pencil here to just mark the new valley lines that I did with the hinge move. So the new hinge I put up is this one. see that even that extends into my, actually it doesn't. So what we want to do now is for everything to sort of just fall on these two. So instead of closing toward the, so you can choose two mountains to fall on. I don't know if that makes sense, but here's how that looks. So I make sure that it looks like this. So I'm sort of, this is the space we have yet to find divisions in. And everything else just going to sort of just like an accordion, just fall. Everything is just going to go mountain, valley, until it hits this point where it can't do that no more. And so it looks like this. And so here what I do is I just take the hinge also and I put it, well in this case to my left. And then I can sort of unfold or leave that folded in actually. I can leave that folded in. And then do the other hinge as well. So because it's 9, the divisions should, in order to keep a balance, which is sort of split in half, there should be 5 on one side, 1, 2, 3, 4, 5, and 4 on the other. 1, 2, 3, 4. In order just to keep a balance, but it's only because it's more based on the 3-ness than 4-ness, so, or any 2-ness. So divisions in 2 will result in some odd configurations. So fully extending these. So I'm pretty confident that this center is split into 18ths actually, but I can also take it as a 9. How can I take it as a 9? Well, what you do is you take it as though you're counting only either the mountains or the valleys. So there's 9 mountains and 9 valleys going around here. So I'm going to do this color configuration on the back. Let's see. Use red and green. So mountains on this side are going to be green. And valleys are going to be, so notice how if I do it like that, how the lines, when they hit the center, they don't continue as they are. How are we doing, Jeanne?
I'm getting there. It's kind of sloppy, but
Did you do the moves that I was suggesting with the sort of the extension of the lines and all
I
this and the
did.
crunching?
I'm doing the extension of the lines, but it was very unsystematic the way I went about it. But I did that.
Oh, that's fine.
And I don't know how accurate it is, but we'll see.
Well, here's a quick way to test it.
Yeah.
That's how
sure.
accurate it is. You simply have to go like, just collapse it.
Yeah. It's actually a lot easier to do it this way.
And then by compass.
Oh God, this is very inaccurate. No, I found it easier to fold, although there's a problem somewhere.
On this triangle, on the one that sort of we divided. Or do you mean the easier because of the not sort of matching to the edges, but rather the extension of lines?
I found this was a lot easier than the first method that we used. Yeah.
Yeah,
So
I agree.
for some reason there is a mistake here that I gotta fix.
You can also sort of try and have the shortest edge here as your two mountains that you're going to fold toward.
Okay.
And then just sort of collapse on there, and remember that it's sort of 5 on one side and 4 on the other. So it goes like, 1, 2, 3, 4, 1, 2, 3, 4, 5. And so the advantage to doing it toward this is that you can see every other edge after it. So also, if we were to cut here with some scissors, we would get a nonagon, if you will. So on this line, everything that's after this line is not a nonagon. We have an exact nonagon right there. So we could cut it and just have a nonagon, work on that, which is fun too, because just have an exact nonagon and just play around with it. But the pattern we're going for requires us to do a little bit of a different trick. Although I'm having my doubts if we should go for that Islamic pattern or we should more like try and play with this figure first.
I think we should play with this figure first.
All right, so in that case, let's cut at the nonagon. So if you have an X-Acto knife, or maybe, well, yeah, so to get familiar with the shape, I think the first step is to play around with the polygon figure of it. Everything else just sort of come out after that, but let me just put this little emphasis here on this point before we cut. I just want to mention that in the case for the Islamic pattern that this would sort of inspire, or like is what we're trying to do, all we really are to do next on it is to bisect these 3 angles. So I'm just going to refer to a little bit. So it's this angle, this angle, this angle. So it's like those two. This one actually is not correct because there's no triangle there. So it's more like this angle right here. So if I can bisect, for instance, this corner, also the advantage is that we simply have to do it once. Now I'm just going to show you, we're not going to do it. We're going to cut the nonagon and sort of play around with it, because it's a lot of fun to do that kind of stuff. But just to show you a little bit. So if I have a mountain here and then I fold this valley thing here, I don't know if you can recognize there that what we need next is, so if we had a compass, not a compass in straight edge, it's the compass, we can sort of do a little bit of a circle of the Islamic circle packing that produces this pattern. So for instance, on this intersection here, we sort of would, well, we have to find the perpendicular too. So we still need that point, that perpendicular line. But we do have a point. And so on that point, we would get just a little perpendicular line toward the edge here. And go from that point toward the edge. And so we can do a little compass thing on there. So from here to there. So there would be a circle here. And this is a circle that would encapsulate sort of the star that goes out toward the 9-fold star over here. So then it would just be a matter of which angle we want to sort of come in toward the 9. You do it in perpendicular fashion or whatnot, but this is sort of the approach to it, but we're not going to do it right now. What we're going to worry about is the nonagon plane. So another way, so there's several ways to do it. If you have a pair of scissors or an X-Acto knife, it's the easiest way. But if you want to do it the long way, for whatever reason, what you need to do is just to keep in mind where your vertices are. So for instance, my vertices are here for this one. Are here for this one. So the line I'm looking for will be perpendicular after that vertex. So all my red lines are going to fall on themselves, for instance, here. And they're going to come in from where the green line hits the edge. And then where that hits, then I would sort of go around. And so that's the idea, right? So this is the move. And there's several ways that we can achieve this. We can also just like do it once and then just do a little like a mirror thing on it. Again, sorry if I'm just jumping over steps.
Can you just do the very first step one more time? Just
Sure.
so I can get started. Okay.
So yeah, so for this one, we keep in mind the vertex. So in this case, it's my green line here.
Right.
So where the green line hits the edge.
Okay.
And then what I do is I make sure that the red line here falls on itself.
Of course. Okay.
After that.
Okay.
So now with that folded, what I'm trying to think about is, well, how is this going to sort of, travel around the center? So there's several ways that we can do this, but one way I like to do it is by mirroring. So I can turn it over. And well, here I don't have it color coded, but you can see at least that, like this edge here is the same as this edge here. So now what I do is I look at where that edge is. It's a valley. Because I turn my paper over, right? And I had it, so I started the fold sequence on where the vertex lines were mountains. So when I turn it over, those are valleys now. So I have that valley and I fold it. I'm not committing to the rest of this, although, why not? But, don't have to. What we really need is for then once that's folded, then we just sort of line up to make sure that that line falls on the bottom edge, if you will. And you can see also that this red line is going to fall on itself a little bit there. And then that red line gets activated. Sort of it does this little move there. It's getting tucked. And so that can extend. And we do the same thing with the red line, green line, lift. And all we really need is this line. We don't have to extend all the way. You can also do it on the other side. So again, this is the roundabout way. Not the roundabout way, this is sort of the way that we're sort of going around. And as you can see, that pretty much solves for half of this nonagon. Because this would be the symmetry line right here. So I have two options. I can either keep this going, or I can start over at this side and just sort of go, again, tending towards that point. The easiest way, I have to insist, is just to sort of collapse everything on a single triangle and then simply just cut this edge all around. So it's just pretty much the same thing. So once I hit my second line, boom, one line.
Ricardo,
Yes. Yeah, this
Can
is
you
getting
just,
off.
can you just like start side? Yeah, I just gonna follow you from here. Here we go. I got my
Yeah,
first.
okay. So the first line I did was there. So, you know, there's several ways that we can sort of approach this. We can find points, and then on that point, we can then sort of take that and have it land on the line it's on. So point, hits, and then we find another point there. And now we can take on that point, and we make sure that this line falls on itself from that point.
But you don't see the point until.
Well, I can sort of tell because of the line that's sort of that's there folded, but maybe it's because my eyes are really sharp for this, but it doesn't hurt to sort of.
All right, hold on. I guess I just, honest to God, I just missed the second fold. I got the first one. That's fine.
Yeah, so first one, boom.
Yep, got it.
And then on this point,
Got the point.
the point where this fold hits the vertex line, if you will.
Yep.
So
I'm
on that
there.
point, we can mark it on both sides if that's easier.
Okay.
And then we make sure that the result, the next fold is
The next fold. Oh, so you turn
from that point.
unfold.
And yeah.
And the corner goes up. Oh, okay. So then, okay.
So notice how it goes from red to green, right? Because
you
it goes
like-
after the center.
So you're lining up the red line when you fold, right? Is that
Yeah, pretty much. Yeah.
Okay.
But it lands on the green because after the center it changes color, but it's the same line. You can see there that it's landing on the green.
Yeah. Okay.
And so now I have a new point where that new line hits the green.
And then you fold up and match up the red line as you go up.
Yeah.
Okay.
So now on that point, same thing.
Okay. Okay. I got it. I got it now.
Got it. Cool. One of them is actually the radial line. No, not the radial line, the line of the triangle. Yeah, I believe that it doesn't hurt to actually, you know, mark them on both sides, because when you fold them, you don't see them because you know, you only get to see the paper overlaps, so you don't, so it becomes invisible.
When I line up the orange line,
Mm-hmm.
is there any other place that any other points of matching? Or
Well,
any points hitting?
there probably is, but
Bingo.
I would insist on those because that's the way that we guarantee perpendicularity. And that's sort of the thing that makes it a regular polygon. This line is perpendicular to this, to its apothem.
Yep. Okay.
So it's a very powerful reference, if not the most powerful. But the sort of the takeaway or the risk is that the fold we do does not go through the points that we're looking for. That's the risk. So that's why also I would suggest to mark the points on both sides, because that would help us to make sure that the line goes through them rather than not. I'm going to draw here the points.
Okay. Okay, it's all good.
Right on.
Wow.
So
This is
pretty
great.
much, yeah. It really does. So you can actually extend these lines, and you're going to see like partially a 9, what would it be, 9-2 star. The 9-3 is going to be incomplete. All the stars are going to be incomplete because it is the biggest sort of nonagon inside of the triangle. You can even see the triangle here. You can see the triangle there. And sort of the nonagon is built inside of the triangle as though the edges of it were sort of what's limiting its construction. So what we want to do next is pretty much either, eliminate. I would do that. So we're going to extract this nonagon from this piece of paper. So we're going to have to add these. So we're going to do the same thing as we did before when we cut, which is if we have a valley, we turn that into a mountain. And so we can sort of have the fold be weakened by it being both states. So when we do a fold, it's not automatically a mountain and a valley. It's either a mountain or a valley. But we can do that fold inverted, make a valley into a mountain and such. But it's a separate fold. It's just sort of they're riding on the same line, but it is a separate fold. And so what's interesting to think about with that is that when a line folds a valley and then you fold a mountain, and then it does this thing where it can sort of be one or the other, you're actually transferring from one fold into the next, sort of. So, but this can only be done, or this can only happen once you fold both ways. Folding one way will not give you the ability to sort of just jump back around. You can think of this as though it were a wooden cut. And so a wooden cut would sort of guarantee that you can fold like this, but if you install a hinge, it actually can go both ways, if you will. So when we do the fold both ways, we are actually sort of installing a little hinge that the fold can go one way and then go the other with minimal effort. If anything, it will just try to ride on any other folds that are there and get in the way. But now that we have this, we can sort of just cut. I rip on one of those, and then I just make that rip travel. So I hit my point, and then I change directions. And so I hit my point, and then, because of the same sort of pressure that I was putting the folds of the nonagon on, it sort of very naturally just sort of travels. Yeah, so now we've extracted a nonagon here. That wasn't so hard, was it?
No.
See what I was talking about, sort of like using this as a hack or as a sort of a tool for other things. So you can sort of take this nonagon now and put it on your tracing paper and go like, you can actually see the branching lines and sort of use that, right? So it becomes like now you have a homemade nonagon.
Mm-hmm.
But we're not done yet. So once you have it as a nonagon, it's a lot of fun to just sort of crunch it and go up and down, sort of this little configuration. It's interesting because by perspective, we can create the stars. It's still a flat piece of paper, but because of the mountains and the valleys, this sort of lifting, and you can sort of squeeze it to a perspective point where this line is actually seeming to go into this other one. And we can keep pressuring it. Of course, it goes to the end, but So by perspective, we can see then sort of this sort of arrangement. This line going into this one, this line going into that one. Still a flat piece of paper, perspective. What's interesting is if you do this and you sort of look at it toward the side, that is, if you take your eyes from here and then sort of take them to here, you're going to see that not all the lines are touching the surface. But it's interesting because if you could find where all these lines are touching the surface, now you would have a 3D star that would look like that. So it's almost as if you would imagine a knife sort of just hitting on the highest point. So for me, it's like the vertex is what's not touching the ground. So if I could just sort of imagine like a laser cut with just on this C point. So the C, I mean that my hand is not touching the ground, rather it's a little bit high. So on that point where that's the vertex, just slice it, and then all the lines would be touching the surface, and now I could just line it up like as though it were an object. Because those lines that sort of make things fall flat are also non-trivial, like they are quite special. But because it's just a flat nonagon, I can just sort of push on here and see that this is what's happening. It's a nice little trick, little magic trick, little effect. It only works on cameras though. Just a top-down camera, you just sort of see there. That's a nice little trick. So it can go back one way, it can go back the other. So now I'm going to teach you about sort of the nested star bit, because that's how we play with these things. That's one of the big ways of playing with these things. So first off, we're going to sort of, you got it?
Yeah, it's just so, just makes me feel happy. That's all.
Oh, yeah. Oh, that's so good. So good to hear. And so we can also take what we learned from the Islamic rosette building and apply it to here, because a lot of the Islamic rosettes are simply nested stars. So we can do a little 9-fold rosette on this little thing, and it'll be pretty cool, look pretty. And so, but with that in mind, so let's take into account sort of what we're trying to build. So we have to choose a star first. So which star are we going to choose? So we have the, let's see, let's go over our catalog here of stars. Let's see what we're working with. So we got the 9-2, we got the 9-3, and we got the 9-4. So all these are inside of brackets. Now, why we went over this last time, right? With the N and the K number. So K has to be higher than 1. K has to be less than half of the N number. N is a polygon number. K is a star polygon number. So we are using N equals 9. So K can only, in this case, so when N is 9, K is, well, can be, I guess, 2, 3, and 4. So these are our stars. So these two are the unicursal. So 9-2 and 9-4 are unicursal. 9-3 is not. 9-3 is a compound star polygon because 9 and 3 have a common factor of 3. Therefore, this can be understood as 3 brackets 3. So this is 3 triangles. This is usually what I use as a guide when I draw freehand nonagons. And that is, I sort of just begin with 3 points, and then I know that between there's going to be 2 points. So 1, 2, and 1, 2, and 1, 2. Sort of trying to imagine the points being on a circle. And these can all be sort of triangles. Right? So this is the 3-3. Well, the 9-3, if you will. So we're going to start with some unicursals. Let's try with the although the compound star polygons are pretty come in handy. We're going to start with the 9-2, and then we're going to take a 9-3, and then we're going to go back to 9-2. So we can play songs almost, like we can choose which notes to go after which notes, and then try to find different harmonics and where to place them. So this is the analogy for songs as well with this kind of thing. And what's fun is that we also get to decide where these lines are going to match. So what I mean by that is, do we put our star on the green line on the vertex, or do we put our star on the red line on the apothem line? So these two will actually result in different configurations. So we're going to start by folding on the vertices, just because we're going to actually fold the same star on both the vertex and the apothem. So let's try and begin with the basics. So let's go for the 9-2. So we go 0, and this goes either way. That's also why we use that second rule, this K is less than N than half of N, is to guarantee that we can go either way when we count. Because if we didn't have that rule, then we said like 9-6, we would have to go 0, 1, 2, 3, 4, 5, 6. But this could be the same when counterclockwise we go 0, 1, 2, 3. So to avoid confusion as to say that 9, 6 is the same as 9, 3, we simply say no. After the middle line, we stop counting. So 0, 1, 2, 3, 4, that's the last one. So it goes 4, 3, 2, and 1. 1 is the polygon shape itself. 1 is the 9. 9 over 1 equals 9, right? So we go for the 9, 2. So we're going to start by folding this. So a trick I like to do is to select in a mountain the lines I want to fold the star on. So if I want to fold these two lines, like so, like to select them, almost. And everything else can just fall like as it may. You know, it doesn't really matter if you don't sort of complete with the inside. What I like to sort of guarantee is just that on both sides, it's flat. That I can see on both sides, the full sort of space. The advantage to this sort of approach is that when you lift and to draw the star in, it sort of touches on where the paper is stretching, or not stretching, where the paper is limited by. You can see there that it hits on the corner here. You can see that it hits on the other corner. So this is the advantage of this method, that we can sort of use the limits of space itself to draw our star. So there's also a way of sort of circumventing any other sort of relationships or references. Because what we care about are two things. One, that this line falls on itself to guarantee a perpendicular line here, and that it hits the vertices. And because we sort of extract or select the vertices in this fashion, they, you know, it's a pretty, you know, I won't say ironclad, but that's a weird word, ironclad. It's a powerful way. And so once we have those two, so I have these two done, so I have 1 and 2 done, I unfold, and then I go to the next one. So I pull on this valley here and activate this mountain that's in the middle, and just sort of pop it now to the side. And then on the back, well, to keep a balance, I'd go the other way. So on the top, I go from right to left. On the back, I go from left to right. And now I have two different, which don't have the folds in them. So again, so I was here. This is where I was. As you can see, that's already folded on both sides. Now I activate the mountain that's in between, and I go one way. So this is sort of tucks. And now I can see that this line is flat. And I go the other way on the other side, just to keep a balance. But this is optional, you know, as long as you can make sure that you do all 9 of them, whatever way you want to do it. So this is one way. This is the way that I prefer to do it. It's the most meditative, or rather when you can just do this sort of with your mind turned off, then it is pretty satisfying. We see some of the rum shapes coming in the 9-2 with this one. At least, no, it's not. No, forget it. Spoke too soon. So yeah, one way, the other way, one way, the other way. Then you unfold, and you do the other line. And then over here, same thing. And so how would this look if we had it as an open? So because it's unicursal, you know, if we keep this going as so, we're going to see that when we continue, for instance, here I already have 4 of them. If I wanted the next one, this one is actually incomplete and getting in the way. I need to put in some bigger blinds or something because the light is still burning. So you can also do it like in the air. You can do it like through this way. of just making sure that it's going on vertex 1 to vertex 2, or rather vertex 0 to vertex 2, and then you can sort of just go 1, 2, 1, 2. So whatever works best for you, whatever works best. If folding like I showed you is better, then do that. If you prefer to just see where the fold hits and then you unfold, and so you just go around, that's also good. But what you want to do is you want to make sure that, you know, the lines are perpendicular to the center, to central division. And so by doing these sorts of play things with them, you get to now have an actual sort of star. And this actually will sort of match there with the ground. So it's a nice looking thing. It's pretty basic stuff, you know. Can you pop it one way or pop it the other way? Now here comes the interesting bit. So actually I'm going to draw these lines into this thing. I'm going to draw them in pencil on the side with all the radial lines. No, you know what? I'm going to draw them in pencil on the side with the pencil. So there you can see the 9, 2 on the vertices. So now let's put in the 9, 2 on the apothem line. So same shape, but now we're gonna, so if I have them as mountains here, if I have my 9, 2 star in a mountain, I'm gonna do the 9, 2 on the apothem in a valley. It's gonna go 0, 1, and 2 here. Nope. So for the apothem lines, I find that, you know, the first method I showed you could be a better way to approach this, but, you know, not a guarantee that that's the best way for you. I still like to just go for a point. So I find the point that I'm going for, and then I just make sure that it's perpendicular, and then pretty much automatically it'll go to the other point line. You can see that this happens too. And we can actually make a little square if we tuck that in perspective again. Boy, that sun's coming in hot. So remember, the apothem star and the vertex stars have to be in different states. This is to guarantee more interactivity. But what's fun is to be able to, you know, at least go 3 levels deep with this. But then the question is, well, what do you mean levels? I mean, if we're at the apothem and the vertex line, I mean, do we just put all the stars in there? And the answer is no. We find intersections with the radial points and put more stars there. Or the radial lines, sorry. So by radial lines, I mean either the radial lines, so the lines that go from the center toward the vertex, but, you know, maybe due to a lack of a better word, I also am referring to the apothem line. So when I say radial lines, I refer to both the radial lines, the actual radial lines, and the apothem lines. And the reason being that both lines are dividing the circle. So they are part of the, I mean, one is a circumscribed and one is an inscribed circle. So both of them could be interpreted as sort of radii, sort of. Now I'm finding out that I should have done them backwards based on my arrangement. And by arrangement, I mean the folds I have for my radial. So I don't want to change my radial lines. Those are like the guiding stones for me. So I'm going to change all of my folds to whatever it is they're on, so toward back. So if I have those values, I'm going to change me. I don't know how you are, but I found that for me, this is going to be better. Actually, these stars do benefit from being both ways, because sometimes there's going to be an intersection happening or something's going to be making it want to, you know, change at any point. So it's going to be, it could be partially a valley and then become mountain. That does happen. So, you know, just to be preemptive here, you could also fold both lines both ways. Okay, so I have that one both ways, and now I have to fold the other one both ways. No, vertex, vertex, there we go. So I'm just folding, and then I unfold to go to the next one if necessary. After 4, you know, that's going to happen. Just a fly in the room that I'm sort of looking at. It's sort of not distracting me, but I am sort of checking its path, seeing what it does. And so with those lines in, I can do this little trick where these get tucked in there, and now they have this little ridge. So this can happen, you know, multiple times across our pattern, but it's an interesting fact that actually there is a deep and powerful interaction between the same star on either the apothem or the radial line. Maybe I should just call them like that, apothem and radial lines, instead of trying to make both of them synonymous, because they're not, but at the same time. These are the breaks. So now it looks a little bit like this, which is cute because now it's sort of like it has a little tuck there. I like it better on this side, but we're not done yet. See, this is the first sort of step. And now this can sort of guide us into where to go next, because if we can see this and appreciate this mechanical movement on this one, so we can see like, oh, this is nice, it's sort of tucking in, so what can we do next? And we see that, you know, here is a nice little pressure point. So we could establish that as our next sort of move. We could put it there, or we could put it here as well. We could put it on the line that's touching on the red here, the next star, or we could put it on that intersection. If we put it here, it's going to tuck very nicely. If we put it here, this is sort of going to go into this point, sort of going to go within. So I think that's nice. So we're going to choose these. So this is going to be our next sort of star pattern. So it's going to be here on these red lines hitting this. So I'm going to turn it over just to see. So here, 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 and that's it. So I didn't actually mark this. So apparently it's on the apothem star, where it hits the, what is it? Must be the first apothem that it hits the next apothem down the line. All right, so on those points, we're going to go now to the next star. You can either go for another unicursal or go for the 9-3. I say we go for the 9-3. So just on the basis that it's sort of the next star. You can make it another 9-2, why not? But let's make it a 9-3. So it's going to go 0, 1, 2, and 3. 0, 1, 2, and 3. It can go either way. So it's from here to here. That's the idea. So I'm going to use it on this side because I can see the point, so I can do a little mountain on this little mountain fold. Maybe mountain folds are better when we want to connect points because we can see the space. So I'm connecting that point to that point. And then once that's folded, I can just lay it down on the ground and just make sure that it's a straight line, because it will happen, at least it happens to me, that when I do these kinds of folds, you know, there's a little, so I'm going to do the fold both ways. There's a little curvature that happens because I'm in the air. Sort of an accidental squeeze that just makes it go like that. And just making sure that that's sort of working for me. Okay, right on. So it is. So next one. So again, from there, 0, 1, 2, 3. So on that point and on that point. So even I can avoid the fold entirely and just fold like the points. And once I have the points, then I just sort of have to match this line there. And then that's pretty much going to be it. Like this will sort of collapse. This will just be like, ah, this is what you want me to be, fine. So I know we should be waiting, or at least like fold it completely before we sort of try to activate this more. But I get very impatient. I'm always trying to see like, wait, how's this gonna look? All right, so next one. So again, I select the point on the other side too, and fold there. Now again, both ways, so one fold, and then I turn the paper over and then do the same line, but on the other state. Make sure that it's all going right, good. All right, next one. Goes from here to there. So this idea of nesting stars is pretty much it's very prevalent in the Islamic arts, and the rosette patterns that they come up with are a lot to do with these sorts of configurations. Now, what's interesting is also how to, well, how do you find more of the proper configurations? And by that I mean, how do you know which combination of nested stars will result in a rosette or a pattern that is pleasing? And the answer, at least for me, as of now, is that I don't know. There is this paper, it's very, it goes around, it's called Rosette Analysis. And it pretty much just goes over how to construct these sorts of rosettes using circles and the sort of rules and limitations to take into account and whatnot. I've gone over it a couple times, but I've yet to sort of fully grasp the how to choose which is which. But that paper does show a lot of examples for several of the polygons, so it will do that. At the same time, a rosette is not always just a star pattern. There's several times where the central star will then be decorated by some other geometrical thing. So that's also interesting to take into account. That we're not really limited by these shapes. We're rather just informed by them. They always can produce more things that we don't yet see. And they're not strictly, yeah.
Did you say who wrote this paper that you're talking about?
No, I forget, but I do have it. Are you on the Discord?
I just discovered what that means today, and I don't really completely understand what even it is yet, but I'm working on it.
Yeah, well, it's a platform that people use to organize with their friends for online gaming. Oh. So it's almost as if, they're doing some online gaming, and the game they're playing, needs them to sort of organize, or they're playing for a quest or whatever. So that's where they can either voice chat or just post updates. So if the group is bigger than 3 people or 5 people, then they can sort of get together, or if they're trying to organize for a certain whatever, that kind of thing. So it's like a community space that is usually like invite, you get in through invitation, or because your friends sort of, you build it with your friends, or that kind of thing. So it's not like other platforms where you can just publicly just show up. Although you can, sometimes there's a Discord server where the link is publicly available on somebody's blog or something, like, hey, if you want to join the discussion, here's the Discord. Or, Patreon actually has sort of the inclusion of Discord servers. So that's almost as if, hey, if you want to join the discussion for whatever it is we're doing on Patreon, join the Discord. And it's a little more private. There's no regulation. So if you're, talking about controversial things or crazy things and you want publicly out there, then it's a great alternative. And what I'm using it for is to publishing not publishing, sharing academic papers related to either Islamic patterns or mathematical origami, or just mathematical or research onto folds, that kind of stuff.
So I can get there through being a Patreon.
Yes.
Okay.
Yes, you should. I don't know how, but you should be able to just
all right.
Just get in there by Patreon. Okay. And once you're there, there's this little channel they're called, where there's all the academic papers that I've been posting. And I haven't posted it yet, but I can find it easily. I mean, if I just search for Rosette Analysis, Islamic Pattern, and academic paper, it'll probably be one of the first to come up.
Okay.
But I think somebody sent it to me before, so I can also go through my emails, and it'll probably be around there somewhere.
Thank you.
Yeah, no problem. So here I'm just really marking the 9-3 on the point we established, which seems to be an apothem for this nonagon here, for this line that's there, right here. So if I'm going to keep this idea of the nested stars, now I'm going to use these vertices as the basis for the next star for the same 9-3, but now on these points. So it goes 0, 1, 2, 3. And I'm going to select them with a cross. Yeah. Goes 0, 1, 2, 3. Again, it will help to have the line, fold both ways. And there's a nice intersection for this star. So this star actually is very closely and intimately related to its counterpart. You're going to see several intersections sort of automatically come up. And some mechanics too, apparently. It'll just fling into operation quite quickly, very quickly. What's fun about this nested star sort of approach is that you get to have this little circuit board, if you will, or just this thing that's sort of reactive to pressure. And so you can start to play with the way the lines are going either up or down. Also, one of the reasons why we fold the star both mountain and valley, because an intersection might just be a transforming agent. And by that, I mean that an intersection of folds could be where a fold changes from mountain to valley or something like that. So I get impatient sometimes, as I've said before, and it does happen that I try to fold the thing before I should, because I should really just keep going. Because if the folds are not completed yet, then it won't properly activate. But I'm seeing that there's this very pleasing sort of movement here happening. I like the way this is going. So again, I'm just gonna have to keep this going. So it's 9 lines, it's not that much. So, in a way, folding is easier than a lot of things, but in another, it is more challenging. It's more demanding in a way. In another, it's just so much more varied. There are many things that you can do with it. I mean, approaches you can take. I'm finding that this line actually matches to the other star. Mm-hmm. So that's a good sign. That's a good sign because it usually suggests that there is some underlying harmonic to this step, because we're sort of inside, right? So we're inside the 9-2, inside the 9-3. So the fact that even to this step, or rather the fact that we are within and still finding nice relationships to the full figure, means that we might be sort of hitting on something beautiful, right? Or something which is harmonic. Sometimes that happens, sometimes it doesn't. I mean, sometimes you can still produce harmonic objects and not have these sorts of relationships, but it's nice when we do, because it also suggests that there's this basic or elemental, rather than basic, elemental aspect to this approach, or this pattern. So if you're watching the recording, I'm thinking that it's going to be either boring or difficult, because I've been getting out of frame a lot today. I should really put some lines on the table here. Let's see how many lines am I missing. Well, still some. So now, because of the intersection also that's happening on this point right there, I'm also going for it. So I'm also, when I'm folding this, I'm going from that vertex to that intersection to the next vertex. And this is fun. This is fun for me. This is nice and you know, gets you out of your brain a little bit. It's a fun little toy. I say these are toys. There we go. Missing apparently just one more. And you know, there's no limit as to how many stars we can put inside. I mean, we're limited by how well we can see, and we're limited by how big our paper is. And also, of course, by how rigid it is, the paper. So if it's too thick a paper, then of course, it's going to be more difficult to sort of appreciate the movement, but maybe that's not a key factor as other things might be, as our patience. So this configuration I'm going for pretty much is exactly at the outer edges like the first one we did, but on the inner I am using, the 293s to sort of do this little figure there. It's quite interesting because it's tucking into the center polygon, as you can see there. This line sort of gets tucked. This line is also there combining there. You can see that happening on the other side. So I am aware that this just sort of just really rises up in the difficulty curve, just like, I don't know, it's just like from 0 to 100, just boom. And the thing about this, which is difficult, is just to be able to sort of, you know, just crack and compress and get the right point to work for you. And it can be quite frustrating if you don't sort of know what you're doing. But the thing to take into account, at least for me, that really helps me in my mind, is to know that the paper doesn't need you. All the paper really needs is your guidance. So you just really have to touch it. It's a very sensitive thing. I mean, look, right there, I didn't do anything, just a little bop. And it's a matter of, so that bop will select either this line to be flat, like so, like a little platform there, or I can bop it. And now it's a line that goes straight toward the center. But it's just a little pressure point, just boop. And then everything just changes. Everything, just the mechanics of the whole thing just instantly change. And so same thing. And another thing is that until you do it, it's going to be there. So once you do it, it's there. You don't need to sort of keep trying to hold it together. I mean, some tessellations do require that sort of approach, but not this one. I mean, this is pretty lowbrow, pretty basic stuff. So it goes, you know, it's not trying, what I mean by basic is that it's not mechanically, you know, unjust, or it's not taxing. You know, once you, wait a minute. My earphones, these Bluetooth things run out of battery. So these tuck, and now I like this to go out like a star there. You can see that the star is inside of the star. This is a nice little tuck motion there. But see, once this is complete, I can leave that alone. I can just go on to the next one. So I can sort of start to see the star that I'm going for, and I can, well, that's a mountain. So I activate the mountain side of that configuration. And then, well, I know that that's a mountain too. And that's a value because it tucks that in. And so like that, I can just go one to the next, and then also to take into account is that usually a fold will require a complementary fold. It's this thing I told you about, this thing that the fold needs to exit. So a fold will usually, require you to find what it needs in order to complete the mechanic of it, the motion of it. So for instance, there I can just sort of click it and touch it, just put the thing just barely there. And so it's very slight, the things that we're just sort of touching. It's very sensitive. But once we get where we want to be, it's easier, because then it's just a matter of sort of, then we apply the force, then we apply the final sort of configuration on this thing.
Ricardo,
Yes.
can you just take out, let's see, how can I describe it? On the side that doesn't have the colored pencil,
Yes.
I'm looking just like you. So I've got the three
Yes.
star.
On both the apothem and the radius, right?
Yeah.
Yeah.
So
Both.
I have sort of, I just need a very edge. If I could just get one of those edge pieces to go, the very tippy edge, if you could just show one of the edge folds.
Yeah, sure. You mean the edge as in?
As in the very outer edge of the paper.
The very outer edge of the paper.
Right up at there, right where you're like, right, yeah, exactly that. I just need to see what the heck's going on in there.
So it goes after that point.
Yep, I got that. Got that X fold there.
Yeah.
Got that.
So what I do is I activate the 9-2.
See, that's what I'm not quite sure the 9-2 is. What's the 9-2? What does that mean?
It's the first star we did. So it's the 9-2 that goes from even like the outer polygon here. So it goes from 0,
yeah,
1, 2.
On the apothem.
And the apothem, that's right. Well, this one is the apothem, but we also are using the one on the radius here.
Okay,
0, 1, 2. So it's that. So this little tuck that happens here, this little tuck, is the 9-2s.
On the apothem.
And the apothem and the radius, so it's both.
Okay, so that's
because this line that's coming in here,
yeah,
this line is the star on the apothem.
Yeah.
But the line that's getting the tuck is the star on the radius. So this line that tucks in there, this bisection.
So does it then create another set of folds when you do these tucks? Does another fold like emerge?
No, it's just those two interacting.
Okay, I'm just trying to figure out, there's some kind of like little kite shape that I'm not quite sure what. Can you move to the left?
Kite shape, are you talking about like this one?
No, I'm working on
the outer thing. So you have, but
that
you
right
did,
there. I'm working on that. Yeah.
Yeah, but you did do the 9-2s, right? I mean, that's like the first.
Yeah. Okay.
Okay.
I got that, and then.
So notice how it's, so the apothem one is mountain in my case.
Yep, that's right.
And the radial one is in valley in my case.
Yep, that's right.
So those two combined make this tuck possible with this.
Okay, I'll just keep working on it. Thanks. So the radial, the vertex one is going to be valley. Apothem one is mountain. Okay. Okay. Got it.
Got it?
Yep.
Yeah, cool. So again, we're still just playing. I think that it's still just a very basic figure. I think we can go like one star deeper. How are we doing on time though? 2 hours. Let's see what time it is. It's 9:20. So yeah, I would like to do another star on this one because as of now, I mean, sure, it's nice. I like this little figure. I like the way it looks. It looks very cartoonish on both sides. It looks nice. Some very pleasing shadows, the way it's tucking and everything is just sort of in place. Looks nice. However, I would like to see one more level deeper into this thing. But I don't know if I can do that right now because I do have to take this sevenfold thing that I did to the place where they're going to hold it in. Yeah, duty calls. But I think this is a great little exercise to play with the Nonagon at least. I mean, I don't think we... All right, so if we can actually reinterpret a lot of these folds. So these folds are pretty powerful as they are. We can then unfold this thing and try to find some different mechanical sort of thing to this. We can do that. So that's also something we can try out. So for instance, we can do this in a spiraling motion. You just simply go for the innermost star and then combine it with the other one. And it'll create like this little spiral shape. And it'll start like tucking in, going from one to the other, one to the other, one to the other. So yeah, very easily hypnotized by this, as you can see. You can use those intersections to sort of do a little jump outwards and then try to find another line there which satisfies the same condition we're looking for. It should lay flat. Not flat, but it should be flat on the edges, so on the outer. Let me see if I can get this arrangement happening. Looks more like those satellites that they're sometimes using, like this little spiral ball. You can also pop the center star there to get a little more more personality to this sort of twist. It looks like those orange squeezing things. So even at a very basic, just 2-star within, well, it's technically 4 stars, but even at this level, we see that there's a lot that we can do with it. We can even like try and find ways in order to get this to not tuck, but just lock into position. So it could be something where we can arrange some sort of movement for this access to go into the other side of the thing. And when we do that, it doesn't sort of nullify when the other one does it too. So that's an interesting quest. And there we see that it is possible there. There are some lines here which accomplish this exact thing which I was talking about, sort of the way that it goes. How you doing, Jeanne? How you doing?
I have kind of my own
Got
thing
lost.
on.
Right on. Me too.
It's definitely something. I mean, it's popping like crazy, but I think it's just an organic thing that I just kind of it has to come to me with a feel. I have to feel it. That's all. And so I'm working on that. And I'm getting a little. Yeah, it's very soothing.
Yeah. I'll send you I'll put up the Rosette. I'll send it to you personally too, but the Rosette analysis PDF, because if you can get the idea behind the nested stars, then if you can incorporate that, then you can sort of construct almost any Rosette pattern. We've done one before. I can't remember on which session, but we did this thing where we found that the decagon is actually, when you fold the 10-3 star, the spaces that get folded actually represent the Gericht tiles, just like directly. It's just there. So that's interesting. Maybe that's, I should show you rather than tell you that one, because I just heard myself and it sounds weird, but it's true.
I think my folding accuracy is causing me to have some difficulty.
Yeah, with time.
I'm okay.
The other thing is that even if you have, not poor, but if you have not laser accuracy, the fact that the folds are intersecting and changing state will be enough for the thing to sort of start to jump and play.
Yeah.
It doesn't need to be exact for the mechanics to work. As long as you can identify what you're trying to do, that's enough for the piece of paper. The paper will be like, oh, this is what you want to find.
I think that's a life goal, isn't it?
Yeah. Yeah, we have this saying in Spanish. I don't know if it's in English, but the intention is what counts.
But how do you say it in Spanish?
La intención es lo que cuenta.
Okay.
It's the same thing. La intención es lo que cuenta. La intención, the intention, es lo que cuenta, is what counts.
Okay. Definitely very cute.
So it's very looking like a lot of the Ekaterina Lukasheva's kind of models, just with straight lines. But yeah, just like these twists happening here. So it's like a little back and forth. So if we actually like made more stars, we could like put this inside or try to find other configurations for this within and sort of jump back out. So we can even put like another 9.2 within and then go back to 9.3. And the extensions will also suggest either new centers, very naturally new centers will sort of be suggested, or some other thing could be there that we haven't seen yet. So for instance, I would call this a center. I'll call this a center because it's full of radial divisions, which are all angles of the star. So therefore, the lines that go through that point are similar than the lines that are going through here. So we could just finish describing this one, and it could be like a center just like this. That's where things get complicated. Or that, yeah, I think that would be where things would just get really complicated. But as it stands right now, what I'm trying to get is just this mechanical sort of interpretation of this, right? To make it like a little tuck, to make this sort of stand by itself, sort of to try and find some locking mechanism for this part of the pattern in order for me to then just have it be held by itself. But I'm finding that some of the inaccuracies which I do have are sort of getting in my own way. But it's fine. Oh yeah, they're not that inaccurate. But it is a question of where this goes up or this goes down. So there it is, at least something. You could tuck that in. Yeah, that seems to work better. This sort of crown tuck that's happening here. Now, some figures have more harmonics than others. I mean, some of them are just like so obvious, and it's just like overly harmonic sometimes, like to not to a fault, but it's just so much. And like an example that comes to mind is the decagon, for instance, or the dodecagon. If you try and do this with a dodecagon, it'll just be like harmonic relationship after harmonic relationship. It's just like a nonstop barrage of just one thing after another, just lining up perfectly. So it stands to reason because the dodecagon is just full of factors, so it's a very powerful number, 12. 10 is different though. 6, well, I don't have to tell you about 6. 6 is just, yeah. But still, I mean, the fact remains that the challenge is to try and find these beautiful things within shapes that have a lot of irrational sort of relationships. And so the star polygons are a way to sort of approach the references through the same figure, so the figure itself. The tortilla mobile is about to drive by. So it looks nice. And so what a thing that I would think about doing to this shape would be, for instance, I can sync these points. That would be more of an origami approach to it. I can try and find or think about other ways to make this relate to itself. Try to find new platforms for it, new shapes that it might pop out at me with. or I could just sort of commit to this and be like, you know what, this is it. This is the thing. And for now, I'm going to say that this is good enough for it to be a thing. Let me just get a little thing happening here.
It's beautiful.
Let's see yours, Jeanne. Let's see what you got.
This is what I have.
Let's see here.
Those are my little corner pieces that I folded under.
Nice.
3 corners, 3 vertices.
Mhm.
Well, am I putting up on the camera correctly? I don't even know.
Yeah, I can see.
So it's just,
Yeah, that's a good one.
it's just, that's all I got. So cool.
But yeah, okay. Once you go for those, I would recommend that you try and find. So once all those 9 are set up, and it's going to be a little more stable. Now you can try to think like within some star within, but it's also like this, step at a time kind of thing. So it's good that you're sort of trying to go for the outer edges first, but once that's all said and done, once that's, once you can crunch it, and then you can try to think about what's inside.
That's exactly what my approach was, because I thought it'd be better to work from the outside in, so it would have.
Yeah. I think I did it too.
Yeah.
But maybe, in my mind, it's sort of like, I don't know, maybe it's a little bit different because I've just done it so much. But I think it's the same sort of approach, or it feels like it.
Yeah.
So I'm just going to lock these into position and we'll call it a day. So thank you so much for being here, Jeanne, by the way. Hope you enjoyed it. And well, if I were to apply this to the Islamic geometry, I would just use the Nonagon with the lines and just put that on my tracing paper,
Yeah.
And that would be like the exact 9s. And then you can just, you can either just do it. We'll see that. We'll see that in next time. So if you join on next Friday, we'll do it. We'll do the pattern now. So now that you got the Nonagon a little bit down, we can try and combine it now and make an Islamic pattern.
Yeah, why not?
Yeah. Or we could try and play around with some other things, like try to see how this could be a tool, I guess. So there's many topics that we could try and take and tackle.
I always learn something, and it's always very satisfying.
Yeah.
So I'm
I know what you mean.
I'm happy with all the things you show me and tell me about.
That's cool. I'm glad that's the case. So let me show you this thing, which let's see here. Where is the chat?
Is your recording still on?
Yeah.
Okay. Are we supposed to not talk during the recording?
No, I mean,
okay.
Totally talk.
So I just want to let you know that my name is actually Jeanne.
Jeanne.
Yeah.
Yeah, sorry, my bad.
It's hard to get names now, especially when they're not.
Yeah, no, especially if I get distracted.
You don't have that name in your sort of like in your native language. I find that hard.
Jeanne, yeah, especially it was Shashi, for instance, like she
Shachi.
feels Chachi, yeah. I call it Shashi, but she's like, no, it's not Shashi, it's Chachi.
But it's nice to be able to say somebody's name right?
Yeah, it is. It is something that's supposed to.
Okay,
Yeah, I feel bad that I can't sometimes say it. Like it's just natural to me to say it. And like for now, like so I don't know why it's so natural for me to be like, "Hey, Jeanne, how you doing, Jeanne?" It should be more like Jeanne. That's your name. Here, I'm showing you 2 PDFs on the
chat.
On the chat, yes. Well, one is a picture and one is a PDF. Let me open them up on the share so that somebody's watching the recording.
Honestly, I'm afraid if I stop that I'll forget how to do what I'm doing. So, all right, I'm stopping. I'm going to go look in the chat. Oh gosh, click to open. Oh man.
All right, so let's see here.
Okay, that makes sense. Let's see if I can get back to where I was.
So, for instance, this is a completed sort of tessellation on the thing. So we see that we have some 12s and we have some 9s. The 12s are the ones in this corner,
Yeah.
and these are the 9s we have here.
Mhm.
So we could also interpret this to be half of an equilateral triangle.
Mhm.
So therefore, this point is the circle we're working with. So it's not the circle, rather the center division of the triangle that we're working with. So if we see it like this as a circle packing pattern, we see more of the division line. So we have, again, so we're just gonna sort of mind this point to the other corner like this, just from there to there. So this half a triangle.
Mhm.
And so now we see how the 12-fold, so if we just, this bisection I was talking about, we see how it hits the bisection, hits that intersection. And then that's sort of where we draw our circle. And so that is a radius from that intersection to the edge. And it can also be here, but it's a perpendicular. So it's easy to draw perpendiculars. And so we can draw this sort of sequence, this pattern, at least this part of the pattern, by folding. At least we have this center 9 and
We have that one.
yeah, right. So we can also see that this is like a quarter of a dodecagon here. It would be like a third of a dodecagon on this part. We see that's like a dodecagon touching a nonagon. Da, da. And now it's just like this matter of the circles. So once the circles are set into position, wait, no, then it's the other one. Right, so this is the pattern without the circles. Maybe I should show the other one, yeah. These are the things. This one. Yeah. So you see how the circles then become, so okay, so we have that this line is sort of a perpendicular. Well, this line is, no, it isn't. We could establish like these 2 points are collinear. So from this circle, so we could just fold like a straight line all the way across. And then we could just mirror that line all over the 9-fold, just making sure that, you know, this line bounces off to there, bounces off to there. And we then have to, well, this line, actually this bisection will have, so we have this one is not a bisection, but this one is right here. So we could like see this extension of the line, and we can bounce this line, hit here. So there's a series of steps that we can do in order to like just follow this pattern based on what we were doing, the approach we were taking. But maybe right now it's not so clear. But this is just like a little preview. But it is a very beautiful pattern, and there are many sort of different approaches, different stars that you can do, whether it be the 12 or the 9 that produce. So the one I'm showing you actually has the, wait a minute. These are curved lines. So, well, not curved lines, it's all straight lines, but the way that I built it was that it sort of produces this effect of sort of like this curvature. It looks kind of curved, like the lines sort of like swell and contract. They're not really straight, like it sort of looks like it's becoming slimmer and then grows and sort of contracts again. You can see that it looks curvy.
The tapers, because the petals are tapered like that.
Yeah, exactly. I think it's more because it's based on this 9 and this 9-fold star here than it is. Well, maybe I think it was that.
So you know what? You don't even have, on some of those intersections, you don't have it when I wish I could just point to your picture, but it seems like there's places where when a star meets the loza, the diamond, you know, when a star meets that diamond, not that one, but it could be that one, yeah. So with that X, where there's that little X right by your cursor, it's not really, those don't, they come out of that X at different angles, looks like. Looks like it's on a straight line through there.
No, yeah, this should be a straight line. Where it does change is, well, this is a line actually. It should be.
You think those are
But
straight?
they should be. But yeah, this one actually looks like a little bit, like it does a little thing here.
Yeah.
But it shouldn't, because this should be straight. We can see this more here. Maybe it's like the effect, the visual effect of the pattern, but this should, the way that because they do change, but they change more on the star shape. But so sometimes what will happen is that this line will not be sort of straight
Exactly.
in the way that it connects to the next one, but it is straight in how this connects to the star shape almost.
Yeah. So the way I think about it is that the line comes in from outside the star straight, but then the stars are all irregular.
Yeah. Yeah,
So-
completely.
So that's why you can get that curved effect. But you think they're all straight going into the star from the
They
outside.
should be, yeah. And
Okay.
also what this effect produces that these two are touching rather than sort of overlapping, because there are some patterns where that sort of overlaps. I think in the Alhambra, these overlap.
Sometimes.
Yeah. So you can change this around and sort of produce these different sort of configurations. And what I like about this is that these petal shapes are the same. So these 6 are the same shape. So that's also like the key thing about these patterns, that these shapes should be the same.
Did you follow those? Are you following the those instructions that Richard had last week?
No.
No.
This is sort of like just me sort of playing around with it. But
Yeah, because I think when I did what Richard said, that they're similar, those hexagons are similar, but they're not all exactly the same. But yours are all exactly the same.
yeah, so that's also the thing about the choice of which sort of pattern, or not pattern, like star to put in or what angle to put in. I think we actually folded this one. Let me see if I have a picture of it. I don't think I have a picture on my computer. No, I don't have a picture on my computer, and the patterns are on the side of boxes, but I will send you the one we did. I think that one's actually on my Instagram feed. That particular one, I believe. Yeah, but I do have to attend to this thing so they can come pick this up. So
Yeah, go ahead.
Jeanne.
Okay, so I'll see you next time. So we got to meet on Friday again, or what?
Yeah, Friday again. So yeah, Friday again, same time. Well, a little bit earlier.
Okay. So I'm always supposed to look in Gmail for a link to the Zoom. That's how it works.
Well, no, the Zoom link should be on the Patreon.
So I go to the Patreon website and I go to this called student link.
Yeah, well, the day before the session, I usually put it up, or it's rare that I put it the morning like I did today. Like today was a rare day, but it's usually that it's posted on the Patreon page, just like that.
Okay.
Day before. But if you join any of the links, I get a message anyway. So I get an email notifying me that you joined.
All right. So what I'm going to do is I'm going to look around on the Patreon website and see if I can find this place you're talking about that has links for students.
Yes, for the Discord server.
Okay, I'll look.
Right? Is that the link you're referring to right now?
I'm looking for it right at this moment.
Mm-hmm. Yeah, I don't know actually how to join a Discord from Patreon.
I'll do my best, and then I'll ask my children.
Yeah. Okay.
Okay.
All right, Jeanne. Well, thank you very much again for being here, and I hope you enjoyed it.
Yes, thanks, and have a great weekend.
Yeah, you too. Take it easy and enjoy.
Okay, bye-bye.
Bye-bye.